application in electrochemical series, that is to determine the product of electrolysis. For example, so electrolytic solution is there, which is dipped into electrodes, and so generally we know very well the positive charge, that means the positive ions will be deposited at cathode because the cathode is having negatively charged, and the negative charged anion is migrate towards the positive anode. Okay, so we will find out which metal ion is deposited. Okay, so for example, the competition between two ions are there. So which ion is deposited, and and also which anion is liberated at anode. So we will see. So before we are going to discuss, here we have some based on standard reduction potential value is minus 2.93 volts. Then Ca plus 2, the standard reduction potential minus 2.76 volts. Na plus minus 2.71 volts. Mg plus 2 minus 2.37 volts. Then Al plus 3 minus 1.66 volts. Zn plus 2 minus 0.76 volts. Then Fe plus 2 minus 0.44 volts. Then H plus 0.00 volts. Then Cu plus 2, Cu2 plus 0.34 volts. Next Ag plus 0.80 volts. Au plus Rm plus minus 1.42 volts. So these are the various metal ions standard reduction potential values I have mentioned here. So here the increasing order of deposition of metals at cathode. So these metals will deposited at cathode. So here the standard reduction potential values going on increases from top to bottom. The age of metal will be increases. For example, Au plus in this series, Au plus will deposited first, then Ag plus, then Cu plus 2 and H plus. So here the metal atom which is having more reduction potential will deposited first. That is very, very important. Okay. For example, the competition between K plus and Ca plus 2. Here we will take mixture of electrolytic solution. In this mixture of solution, it contains two ions. One is K plus and Ca plus 2. Here the Ca plus 2 will deposited first. So because when you can compare to the K plus, the Ca plus 2 has a more standard negative reduction potential than K plus. So the competition between Ca plus 2 and Na plus. So Na plus will deposited first. Then Mg plus 2 deposited, then Al plus 3, then Zn plus 2, Fe plus 2, then H plus and Cu plus 2, Ag plus, Au plus. So this is the very, very important increasing order of deposition of metal ions at cathodes. Okay, remember students. Okay, right. Then we will write some anions. So SO4 minus 2, then NO3 minus, OH minus, Cl minus, Br minus, I minus. So this is the increasing order. So increasing order of few anions liberated or discharge potential at anode. So here, so this is the increasing order. So the I minus is more A's than Br minus, than Cl minus, than OH minus, than NO3 minus and SO4 minus 2. So remember student, most probably, so these anions like NO2, NO3 minus and SO4 minus 2 not A's. So means these anions cannot be liberated at anode. So that is very very important. So only we have these four anions like OH minus, Cl minus, Br minus and I minus. So these anion will deposited will discharge or liberated at anode. So this is very very important. For example, we will take an electrolytic solution. So here the electrolytic solution is sodium chloride. So here we have Na plus and Cl minus, and so it forms aqueous solution. When sodium chloride is dissolved in water, so it forms an aqueous solution. So this sodium chloride solution is having H plus and OH minus and Na plus and Cl minus. So here we have two cations. Here we have two cations. One is Na plus and another one is H plus. And anions, we will see the anions. So two anions we have, Cl minus and OH minus. Okay, so here we have two cations and two anions, right? So the competition between these two cations and the competition between these two anions. So we know very well, so based on this standard reduction potential values, the H plus is more A's so than sodium ion, so Na plus. So therefore the H plus discharge potential is more than Na plus. So therefore H plus liberated at cathode as H2. So H2 is liberated at cathode. Hydrogen gas is liberated at cathode. And also we know very well so about Cl minus and OH minus. The Cl minus is more A's. So the Cl minus discharge potential is greater than the OH minus ion. So therefore Cl2 is liberated at anode. Cl2 is liberated at anode. So this is very very important. So if the solution is a sodium chloride solution, the deposition of ions at cathode and anode, that is hydrogen gas deposit, hydrogen gas liberated at cathode and chlorine gas liberated at anode. So this is very very important. So here a small mistake in that cations side. So that is Au plus 3. So the reduction potential is approximately 1.42 volts. I have mentioned only Au plus. So please, sorry for that, please correct Au plus 3, not Au plus. Okay, right. So here you can see the question was asked in IIT-JEE 1996. So what is the question? A dilute solution of sodium sulfate is electrolyzed using platinum electrode. Here the platinum electrode is a inert electrode. So what is asking the products of at anode and cathode. So what type of products are deposited or liberated at anode and cathode. So here we have two cations and two anions. So here the cations in this solution, sodium sulfate solution, that is cations Na plus and anions, that is SO4 2 minus. So it is a dilute solution, means we are adding some water. So here the water is having H plus and OH minus ion. So first of all we will write the water oxidation reaction. Oxidation reaction of water. So that is 2H2O gives rise to, undergoing oxidation process, it liberates O2 plus 4H plus 4 electrons. So this is oxidation reaction takes place at anode. So oxidation reaction takes place at the rate anode. Then we will write a reduction reaction at the rate cathode. So reduction reaction at the rate cathode. So that is 2H2O plus 2 electrons gives rise to H2 gas liberated at cathode, and then 2H plus H2 gas plus, sorry, 2OH minus 2H2O plus 2 electron gives rise to H2 gas plus 2OH minus. So these two reactions are very important reaction. If water here, so the oxide ion, so this is O minus 2 undergoes oxidation process. O minus 2 oxide undergoes oxidation process, oxidation reaction. So it is liberated as O2. So the reduction reaction at the red cathode, so 2H2O plus 2 electron gives rise to H2 gas plus 2OH minus. So here you can see the cation Na plus and H plus. Here we have SO4 minus 2 and OH minus. We know very well, already we know very well, we have seen the electrochemical series. The H plus, the age of H plus is more than the sodium ion. So therefore H plus will deposited as hydrogen, will liberated as hydrogen gas at anode. So this is cation, sorry. So it is H2 gas deposit or liberated at cathode, and here, so generally already we know SO4 minus 2 cannot liberated. So this OH minus can liberated as O2. So O2 liberated at anode. So the oxygen gas liberated at anode, hydrogen gas liberated at cathode. So but what is asking anode and cathode? So therefore here, so the given option O2 comma H2. So oxygen liberated at anode and H2 liberated at cathode. So the given option you can see. So sodium will not be deposited. So here in both the cases B and C option, sodium will not deposited at cathode. So therefore we can easily eliminate the two options. So option D and option C we have seen. So S2O8 minus 2 cannot be liberated as at anode. So therefore we will remove option D also. So the correct answer is O2 comma H2. So this is a very important type model. Okay, a gas X at at 1 atmosphere pressure is bubbled through a solution containing a mixture of My minus and Mz minus at 25 degrees temperature. So here in an electrolytic cell, so here it is a mixture of solutions are there, that is My minus and Mz minus. So again we are taking X gas bubbling at 1 atmosphere pressure. So he given the standard reduction potential of these various metals or various mixture of solutions, that is the given. So this is conceptual question, students. It is very simple concept. The given standard reduction potential order is Z greater than Y greater than X. It is a spontaneous redox reaction. It is a spontaneous redox reaction. Okay, clear, student? So just we will assume here whatever the metal solutions are there, and X gas is bubbling. So X gas is bubbling means nothing but, student, hydrogen gas is bubbled. So hydrogen gas is bubbled means 2H plus 2 electron or hydrogen gas at 1 atmosphere pressure. So bubbled. So means hydrogen gas is bubbled, and the remaining solutions is a mixture of solutions. So mixture of solution means nothing but, student, whatever the mixture of solutions are there, so these solutions are which are present below the hydrogen scale, below one hydrogen scale. Okay, so the already he mentioned that is the reduction potential of Z and Y is more than X. Okay, clear, student? The standard reduction potential of Z and Y is more than X. So he indicates the X is hydrogen gas and the remaining metals are just, you can assume, copper and silver. Just we will assume copper and zinc. So copper and zinc, copper and silver. So just you can assume it is a silver and it is a copper. So the standard reduction potential, this is hydrogen. So the standard reduction potential of this one is 0.80 volts, 0.34 volts, and this is a 0.0 volts. Just we are assuming that only. Okay, right. So here the reduction potential is more. So generally the reduction potential means the reduction potential more means Z is a strong oxidizing agent. Remember, student, if the reduction potential value more means it is a strong oxidizing agent. It is a strong oxidizing agent. So Z is a strong oxidizing agent. Okay, and Y is also oxidizing agent. So here X is a weak oxidizing agent. The given concept. Okay, so Z is a strong oxidizing agent, Y is oxidizing agent, and this is a weak oxidizing agent. So therefore the oxidizing agent means nothing but the Z has more reduction potential value and it is a strong oxidizing agent. So it oxidizes. The Z can oxidize both Y and X. So Z cannot undergo oxidize, so it undergo reduced. Z is reduced and both Y and X undergoing oxidize. So Z का reduction potential ज़्यादा है, so उसी वास्ते it cannot undergo oxidize, it undergo reduced, and the remaining जो Y and X है, so उसको oxidize करता है. So you can see the given options. Y will oxidize X and Z. Y will oxidize Z and not X. So here you can see Z ka standard reduction potential is more than the Y. So Y cannot oxidize Z. So simply we can eliminate option B. So go for the third option. Y will oxidize both X and Z. Already we have seen Y cannot oxidize Z. So Z oxidize Y and X, but Y cannot oxidize Z. So but it oxidize X. So option C also we will eliminate. The fourth option you can see Y will reduce both X and Z. So Y cannot reduce. So because Y oxidizing agent, Y it is a oxidizing agent and it cannot reduce. Okay. So therefore we will eliminate option D also. So the given option A is correct. So Z is oxidized both X and Y, and also Y is also oxidized X but not Z. So Z को ऑक्सीडाइज नहीं कर सकते, बट Y का रिडक्शन पोटेंशियल X से ज्यादा है, उसी वास्ते Y ऑक्सीडाइज Z, Y ऑक्सीडाइज X but not Z. So therefore Y X को ऑक्सीडाइज करता है मगर Z को ऑक्सीडाइज नहीं करता है, because the reduction potential of Z is more than the Y. So therefore Z undergoing reduced, not oxidized. So therefore the given option A is correct. So this question was asked in IIT-JEE 1999 for 2 marks question.